number 9, we need to solve for x. We're going to replace sine 2x with 2 sine x times cos x. Reason we're going to do that is because we're going to use our double angle identity. If we look at our identities, it says sine 2 theta is equal to 2 sine theta times cos theta. And we can replace that theta with x. So over here, we're going to write 2 sine x times cos x. Then we'll bring down the minus x, minus cos x. Both two quantities have cos x that we can factor out. So we're left with 2 sine x minus 1 equals 0. We're going to set each factor equal to 0 and solve. So over here we have 2 sine x minus 1 equals 0. If we add 1 and divide by 2, we would get sine x equals 1/2. Now we're going to spin around the unit circle and ask ourselves, where is cosine 0? We know that cosine is 0 at 90 degrees and at 270 degrees. So we would say 90 and 270. Come over here, we'll write 90 and 270. And then where is sine 1/2? So we're talking about positive sine. We know there's going to be 2 quadrants where sine is positive 1/2. Sine is positive in quadrant 1. So we'll look at the angle in quadrant 1 and in quadrant 2. So we're not going to look in 3 or 4. In quadrant 1, sine is 1/2 at 30 degrees. If we reflect, we know in quadrant 2 that sine is going to be 90 plus 60, right? Because we spin at 90 and then that 60 degree sliver. So it's going to be 90 plus 60 or 150 degrees. So up here we'll add 30 degrees and 150 degrees. You can convert any of these to radians if you want. So I can go 150 degrees over 1 times pi over 180 degrees. And then if I simplify, I would get 5 pi over 6. So I could write 5 pi over 6. I could write pi over 6. I could write 3 pi over 2. And I could write pi over 2. So I could write it in degrees or radians. All are the same. If we look at this next one, let's scroll down a little bit. It says cos 2x is equal to cos x. What is cos, or what is x? Again, if we go to our identities, we'll replace cos 2x with some expanded expressions. So let's get cos x all on one side. We'll have cos 2x is minus cos x equal 0. Now cos 2x or cos 2 theta, there's 3 different options when we do our replacements. We could replace cos 2 theta with cos squared theta minus sine squared theta. We could replace with 1 minus 2 sine squared theta, or we could replace with 2 cos squared theta minus 1. When I look over here, I know I want to replace with something that says cos. So I'm going to scratch out this middle one. If I replace with cos and sine, I'm going to have cosine and cos. So I'm going to replace with the last one, 2 cos minus 1. So I'll replace this with 2 cos squared And instead of writing theta, you write x minus cos minus 1 minus cos x equals 0. So again, I replace cos 2x with 2 cos squared x minus 1, and then I had that minus cos equals 0. I know that I need to factor this. I can look at it as 2x squared minus x, right? Negative cos x minus 1, if I rearrange this in descending order. And then I'm looking for two numbers that multiply to AC, or negative 2, that add to negative 1. So that combo would be negative 2 and 1. So I can replace negative x with negative 2x and 1x and factor by grouping. So we can replace that center with negative 2x and 1x. And then in front we had 2x squared. In the back we had negative 1. So the left two terms have a 2x that we could factor out. So we'd be left with x minus 1. We need to say x minus 1 over here. So in front it would have to be positive 1. So our factors would be 2x plus 1 times x minus 1. And then we'll put cos back in for x, right? So we'll write cos x. So our factors were 2 cos x down here plus 1, set our factors to 0, and the other one was cos x minus 1, and we're solving, so we set that equal to 0. On the left, if we subtract 1 and divide by 2, we'd have cos x equals negative 1/2. Over here, we would add 1, so we'd have cos x equals 1. We're going to spin around the unit circle and ask ourselves, where is cosine 1? So at 0 degrees, the cosine is 1, so we could say 0 degrees. At 90, it's 0, 1, so the cosine is not 1. At 180 degrees, it's negative 1, 0, so we cross that off because cosine's negative 1 there. At 270 degrees, the cosine is 0. No, can't use that because we're trying to find cosine 1. So the only place when you spin around once where cosine's 1 is at 0 degrees. Next up, we're going to spin around the unit circle and ask ourselves, where is cosine negative 1/2? We know we're going to have two angles. It's all students take calc. We'll have negative cos value in the second and the third quadrant. I'm going to look in the first quadrant and ask myself, where is cosine 1/2? And then I'm going to use my reflections. So I know cosine is 1/2 at 60 degrees. Right, because at 60 degrees we have 1/2 comma root 3 over 2. I'm going to reflect, so I know this little sliver is 60, this one's 30, this one's 30, this one's 60, 60, 30, 30, 60. Okay, so we're going to look at this spot in the second quadrant and this spot in the third quadrant. So if we spin to the second quadrant, we have 90, spin to 90 and add 30, right? So 90 plus 30 will get us 120 degrees. Then, if we're looking for this value in the third quadrant, that angle, we're going to spin, it's 90, 180, 180 plus 60. So 180 plus 60, that little sliver is going to get us 240 degrees. So those three values would be our x, our answer. You could convert these to radians if we want. And so 120, if we convert to radians, will be 2 pi over 3. And 240 degrees, if we convert to radians, will be 4 pi over 3.